Sabrish has a question, or he's okay. Try speaking by fixing your issues. Otherwise, that's okay. He says that when we use this function called random equal to some number, then in this line, random state equal to something. Okay, then each time I split, I'm going to get the same training and test data. Then how can it become a disadvantage? Wherein each time I split the data into training and test, if the training and test data is going to be the same, then where is this problem going to arise? I'll ask you the same question. If I'm going to each time going to have the same data, why do I need to again split it in the first place? If I split the data, each time if I'm going to use random state equal to 0, what will happen? Next time when you try to split, when you try to run this line, it will give you the same data. Each time if it's going to give me the same observations in training and test, why do I even need to split it again second time? The rationale behind taking different training and test data each time is to experiment and to understand whether your algorithm that you've built, does it work well on each different splits or not? That's the idea, simple. When I build a model on a specific data set, and when I test it on a test data set, it will give me some accuracy. Can you guarantee that next time if I have different data set in test, it's going to give me the same accuracy? If I give you a different test data again, will it give me the same accuracy? If it is not going to give me the same accuracy, then can I rely on the model that I built? Because my model is going to give me different accuracy values each time. Okay, when I test it on the test data. Making sense? If I have different test observations, different test data sets, if it's giving me more or less the same accuracy, fine. I'm okay with that. But somewhere it gives me 90%, somewhere it gives me 70%, again, probably it gives me 80%, then the variation is too high. That means the model that I built, it's not working well on all of these. And I cannot guarantee that each time it's going to give you more or less 80%. I cannot guarantee that. Since you cannot guarantee that each time you're going to get more or less 90% accuracy, what people ideally do is they run it multiple times, take an average, and they say that on an average, this is the accuracy that you get. Okay. But when they do this, they also split training data because they want to see what if I have a different data set in training and different data set in test, would the model accuracy values be more or less the same? Or are the model accuracy values going to fluctuate a lot? If it's fluctuating a lot, what should you do? You just take average of all those and say that this is your final accuracy. Making sense? Sabrish, making sense? Okay. Siddhant, you need to check with the concerned teaching associate for that. Coding related errors. Okay.